Welcome back to Step Electrical Friends. Now we are here to discuss on superposition theorem, and this is the very first part of superposition theorem. Okay, so let's start. Before starting superposition theorem, I think you must know these two things. So the first one is replacement of active source by its internal resistance, and the next one is current division rule. So if you have a good command over these two things, then I think you can solve any numericals related to superposition theorems without making any mistakes. Okay, and if you have no good idea about replacement of active source by its internal resistance and current division rule, let's revise it. So the first one is replacement of active source by their internal resistance. And we all know that active sources means either voltage source or current source. So while talking about the replacement of active sources, the voltage source is replaced by short circuit and the current source is replaced by open circuit. And you must also know short circuit refers there is 0 volt and open circuit refers 0 ampere. So with the figure we can understand, suppose this one is terminal A and this one is terminal B. Similarly, we are also taking two terminals small. This one is terminal C and this one is terminal D. To replace a voltage source by short circuit, most of the time we get confused and start thinking either replace this voltage source by short circuit or open circuit. So we all know the voltage source. Voltage source provides the voltage. It means after replacement there should be no voltage. If you short circuit this terminal A and B, then do you think there is voltage drop or rise, that is potential drop or not, rise or drop of the potential or not? No, there is no potential drop, so it is 0 volt. It means short circuit replace voltage source, while current source provides current to the circuit, but after replacement it must not provide the current. So if you keep it open, no, this C and D terminals are open circuited, then do you think the current flows? No, there is no current flow. So 0 ampere. That's why we can understand the voltage source is replaced by short circuit and current source is replaced by, I think you have understood. After replacing the active sources, then they must not function. Means the voltage source provide voltage and after replacement it should not provide the voltage. That's why it is replaced by short circuit. And while talking about current source provide current, but after replacement by its internal resistance, it must not provide the current, that is 0 ampere, that is open. In this way we can understand and we can learn by heart. Okay, the next one is current division rule, and for current division rule it's going to be very difficult to find the current passing through 6 ohm and 3 ohm. So using current division rule you are going to find the current passing through this 6 ohm and 3 ohm very easily. So let's understand this current division rule. First of all, what we will do, we will find the equivalent resistance. So the equivalent resistance of this circuit is how much? 5 plus 6 parallel 3. No, so it is going to be 5 plus 6 parallel 3 means how much? 5 plus 6 into 3 upon 6 plus 3. That is going to be 5 plus 2. So it is nothing, just 7. So here the equivalent resistance is 7, and after that we have to find the total current. Total current IT is nothing, just V by R equivalent. So here R equivalent is how much? 7 ohm, and the total voltage is 30. So 30 by 7 is going to be the total. Okay, and after this we have to find the current through either this 6 ohm or 3 ohm. So if you find the current through 6 ohm, so you will write here I6, and I6 is going to be, and this is the current division rule. So here we will write the total current into, we are doing for this two branch which are connected in parallel. So in denominator we will write the sum of these two resistance of the resistors 6 ohm and 3 ohm. And if you are finding the current for 6 ohm, then we in numerator we will write this 3 ohm. So it is 3. And for I3 we will write IT into how much? In denominator the same thing, that is 6 plus 3, but in numerator as it is here 3 ohm, so we will write here 6. This is the formula for the current division rule, and in this way we can apply current division rule and find the current through any branch very easily. And the total current is 30 by 7. R equivalent is equal to 4.29 ampere. Then after this we will apply the current division rule and we will find the current through this 6 ohm and 3 ohm. So here I3 is IT, the total current, that is 4.29 into 6. We are finding the current for 3 ohm. that's why in numerator we will write this 6 ohm. So 6 by 6 plus 3 is equal to 2.86 ampere. And similarly for I6 we will write IT, the total current 4.29 into 3 by 3 plus 6. Here 3 is in numerator and 3 plus 6 is in denominator. So it is 1.43 ampere. In this way we can apply the current division rule and find the current through any branch very easily. But the branch must be in parallel combination. Similarly, on just changing the side of this voltage source from left to right, let's see the difference. Okay, so on changing the side, the current is flowing from what? Right to left. So here, what will be the equivalent resistance? You can understand here. That is nothing, just 6 plus 5 parallel. Here it is 5 plus 6 parallel, because the current is flowing from left to right. But here the current is flowing from right to left. That's why it is here 6 plus 5 parallel 3. And the equivalent resistance is nothing, just 7.875 ohm. And after that we will find the equivalent resistance, the total current. So the total current is 30 by 7.875, that's 3.8. We can apply the current division rule to find the branch current to this 5 ohm and 3 ohm. So the current through this 3 ohm is IT, the total current, that is 3.8 divided into 5 by 5 plus. Here 5 is in numerator because we are finding the current through these 3, and in denominator sum of these two resistors, that is 5 by 5 plus 3, and it is going to be 2.375 ampere. Similarly, I5 is IT into 3 by 5 plus 3, that is 1.425 ampere. In this way we can apply the current division rule, and I think you have understood this current division rule. So let's start the superposition theorem. So let's start this superposition theorem. Here in this figure we can see that we are asked to find the current through this 3 ohm but using superposition. So we have to follow some guidelines and steps to complete this numerical. We can't use anything randomly. So here 30 volt and this 10 volt are the two voltage sources, and rest of all are the resistors, which are the passive elements. Similarly, we can see another figure. In this figure again, here this one is the voltage source and this is also active source, but the another one is 4 ampere current source. So how to solve this numerical? And let's understand this superposition by heart by doing this, the first one, and then we will also solve this, the second one. So the first one is here. So what we have to do? So according to superposition theorem, first of all, what we have to do? We have to consider only one active source at once and then replace the another active source by its internal resistance. So we have also learned what to replace any of the active sources. We all know that if the active source is voltage source, then we replace it by its internal resistance, that is short circuit. So the figure is going to be like, after considering this 30 volt only, the circuit is going to be like this. This 10 volt is replaced by short circuit to make two terminals. And after that, what we will do? We have to find this current I1, and after considering this 30 volt, we will also consider the current I1 as the current passing through this 3 ohm, and the direction is also assumed. So here the direction is from top to bottom. Okay. So what we will do? How we will find? First of all, we will find the equivalent resistance, and then we will find the total current. After getting the total current, we will apply the current division rule. So let's do. Here the equivalent resistance is how much? 5 plus 6 parallel 3, and that is how much? 7 ohm. And after this, we will apply what? We will use the Ohm's law, that is IT equals V by R, and V by R means 4.285 amp. After getting this total current, we can easily apply the current division rule and get this branch current. We are not going to find the current through this one. Why? Because we are asked to find, we have supposed, and our target is to find this current I1, that is the current passing through this 3 ohm. So I1 is how much? The total current into, so 6 by 6 plus 3, that is going to be 2.8567 ampere. So we have found this current I1. So our first half is completed. Now let's consider this 10 volt and replace this 30 volt by its internal resistance. So let's do. So considering 10 volt only, this 30 volt has been short circuited. Okay. And then what we will do? Thing you know that. So after considering 10 volt, we have to assume that the current passing through this 3 ohm is I2 due to this 10 volt. No. So here we have considered I1, and now we are considering here I2. So first of all, we will find the equivalent resistance, and the equivalent resistance is going to be how much? 6 plus 5 parallel 3. So equivalent resistance is 6 plus 5 parallel 3, that is 7.875 ohm. After getting this equivalent resistance, we can easily find the total current. So total current is I2 equals 10, the total voltage by R equivalent. So it is going to be 1.2698 ampere. After getting this total current, we will apply the branch, we will apply the CDR, that is current division rule, and obtain the current passing through this 3 ohm resistor, that is I2. So I2 is nothing, just 1.2698 the total current into, we are finding the current for how much? For 3 ohm. No, the current passing through this 3 ohm. That's why in numerator we will write 5. Both are in parallel. Try to understand. So 5 by 5 plus 3, it is going to be 0.7936 ampere. After obtaining this I1 and I2, we have to think. So according to superposition theorem, the total current is I is going to be how much? I1 plus I, that is the algebraic sum of the currents we have obtained after considering only one source at once and replacing another source by internal. So in the first case, we have found out that I1 equals 2.8567, and in the second, I2 equals 0.7936. So it is going to be the algebraic sum. Most of the time we get confused, either I1 plus I2 or I2 minus I1 or I1 minus I2. So for this, we have to check here. The direction of the current I1 is from top to bottom. Similarly, the direction of the current I2 is also from top to bottom. And let's check the result. Here it is also positive. I2 is also positive. That's why we have to add these two currents. So we will write here I equals how much? I1 plus I2. That is going to be 3.65 ampere. So in this way, we have completed this superposition. I think you have understood also this superposition theorem. So let's solve the next numerical. So here you can see that this 30 volt is the same as our previous numerical, but the 10 volt has been replaced by this 4 ampere. So what to do? First consider this 30 volt and replace this current source by its internal resistance. As we all know that current source provide current, but after replacing it must not provide current. That is the trick to remember. So just replace this current source by what? Open circuit. Consider only 30 volt, and after that the circuit is going to be like this, is open circuit. And as you know, you can use your common sense here. As this is open circuited, so do you any current flow through this 6 ohm? No current flow through this 6 ohm. No current flow through this 6 ohm. That's why after this, these all are the useless part. Whatever will be the total current, that is the current through this I1. No, that will be the current I1. Why? Because in series connection, the current remains same. First we will find the R equivalent. R equivalent is 5 plus 3, both are in series, that's why it is added. So 5 plus 3 is 8 ohm, and after this we will write IT, the total current is 30 by 8, R equivalent. So it is going to be 3.75 ampere. And after obtaining this total current, what we will do? We will write here I1, and I1 is how much? Same IT, no? So just use your common sense and don't make it more vast. After obtaining this I1, try to remember, we have to consider the current I1, no? And its direction also. So try to focus. And here the result is also positive. Okay, that will be useful in the last. So after this, we will replace this 30 volt and consider this 4 ampere only. So after considering this 4 ampere only, our circuit is going to be like this. So here the voltage source, so voltage source means provide voltage, and after short circuit there is no voltage. So after replacement, it must not provide the voltage. So our condition is satisfied. That's why we have replaced this 30 volt by short circuit. Okay, so here it is 4 ampere, and now the current up to here, the current is same, that is 4 ampere. It means the total current is 4 ampere. So do you think we have to find out the total current? No, our step is reduced here. We don't have to find the R equivalent, and because the current source is given and it must provide the same current, that is the total current, that is 4 ampere. We will write here the total current is 4 ampere. After getting this total current, just use CDR, that is current division rule, and obtain this I2. So for this, I2 equals total current into 5 by 5 plus. Why 5 by 5 plus 3? Because we are finding the current through this 3 ohm. That's why we will, in numerator we will write 5 ohm. So 5 by 5 plus 3, it is going to be 2.5 ampere. So in this way, we have obtained two current, I1 and I2. After obtaining these two current, what we have to notice? Both the result is positive. That's why the total current is going to be the sum of these two currents. So I equals I1 plus I2, that is going to be 6.25 ampere. In this way, we have completed these two numericals, understood each and every step that we have to for solving any numericals and find the branch current using superposition. So what is superposition theorem? So here this is the figure. Side by side, we have also this. You can see in any linear network, and this network is a linear. So if there are two or more than two active sources, there are two or more than two active sources. Here there are two active sources, 30 volt and this 10. Okay, and the current through any branch is algebraic sum of the currents. So the current I1 is the algebraic sum of the currents produced when each source is acting alone. So while considering this one, we have replaced this one by its internal resistance. So for this we have I1, and considering this 10 volt, we have the current I2. So is the algebraic sum. So the algebraic sum is we are either adding or subtracting the current through any branch. The current is I. So the current I is nothing just I1 plus I2. So this definition says that if there are two or more than two active sources, then the current through any branch is the algebraic sum of the currents, that is I1 plus I2, when we consider one source, one active source at once, and replace the another one by its internal resistance. And then we consider the next one as the active source and replace the next one by its internal resistance. So the current obtained is I1 plus I2. Okay, so this is the definition. I think you have understood. So thanks for watching this video till the end, and if you found this video helpful and interesting, please like this video, share this video with your friends, and drop your valuable suggestion in the comment box. And if you haven't subscribed this channel, please subscribe this channel. Hope see you in next video.